Earlier, we defined some important terms in differential leveling: the benchmark, backsight, foresight, and turning point. Now, let's move forward. The question is, how do we actually obtain these readings? We do this through the leveling instrument and the level rod. The level rod is our measuring scale. Look closely. Each large number on the rod represents 1 meter. So this mean can be read as 7 meters. Then the smaller numbers in between represent centimeters in 10th place. So these are the number 10, 20, 30, 40, 50, 60 centimeters. And if we look even more closely, the bottom lines can be read as odd hundreds: 1, 3, 5, 7, 9. Then the top of lines are even hundreds. So this can be read as 2, 4, 6, 8, 10. When we look through the leveling instrument, the crosshairs intersect the rod. That intersection gives us a number which we record as either a backsight or foresight, depending on the situation. Now, imagine our central crosshair or horizontal crosshair cuts across here. That is the reading. That means our reading is 3 meters and it cuts at the bottom line. So that means it is in odd number. So to count, 1, 3, 5. This means it is in 5 centimeter or can be written as 3.05 meters. So let's practice together. So you can pause this video, then go ahead and find the reading. So for this one, the rod reading is 4 meters plus 50 centimeter, or in tenth place is 0.50 meters. Then the horizontal crosshair cuts at the top line. So this means that it is in even number. So 2, 4 plus 0.04 meters or equivalent to 4.54 meters. Then another rod reading. So we have this one. So the reading is 7 meters plus this one is read as 80 centimeter or 0.8 meters plus the horizontal crosshair cuts at the bottom line. So this means it is in odd number. So to read 1, 3 plus 0.03 meter or equivalent to 7.83 meters. So you can pause again this video to practice reading this one. So for this 9 meters, So this is the large number. Then it is then the reading is near this tens place. So 0.30 meters, and at the bottom, so it means that it is an odd number, so 0.01 meters, or equivalent to 9.31 meters. So let's move on to the procedure of differential leveling. So the goal of differential leveling is to determine the difference in elevation between two benchmark, BM1 and BM2. So to start, BM1 has a known elevation from the datum of 100 meters. So you'll set up your instrument between the BM1 and BM2, then reads the backside reading on BM1 equals to 3.03 meters. Then determine the height of instrument on the first setup using this formula, elevation plus the backside reading. So this is the first setup. The height of instrument of this one, given the BM1 elevation equivalent to 100 plus the backside of 3.03 is equal to 103.03 meters. Then since BM2 is far from the BM1, you'll establish your turning point 1, then read the foresight equivalent to 3.86 meters. Then to compute the elevation of turning point, you'll use this formula, the height of the instrument minus the foresight reading. So the elevation of turning point is equals to 99.17. Since the height of instrument is 103.03 minus 3.86 equals to 99.17 meters. Then again, you need to set up another instrument between the turning point 1 and another turning point 2. So the backside on the turning point 1 reads as 2.60 meters. Then the foresight of the turning point 2 reads as 4.53. Then to determine the height of instrument at this second setup, you'll use this formula. So the known elevation from turning point 1 is 99.17 plus the backside of 2.60 equals to 101.77. Then to get the elevation of turning point 2, use this formula. The height of instrument is 101.77 plus the minus the foresight of 4.53 equals to 97.24 meters. Then move your instrument to another setup between turning point 2 and the BM2. So from this setup, the backside of turning point 2 reads as 4.65 meters. Then to get the height of the instrument, the elevation turning point 2 is 97.24 plus the backside of 4.65. So the height of instrument is 101.89 meters. Then get the foresight of BM2 reads as 4.85 meters. Therefore, the elevation at BM2 is 97.04 using the formula HI is 101.89 minus the foresight of 4.85 equals to 97.04 meters. This means that the difference in elevation of BM1 and BM2 is equal to 97.04 minus the elevation of BM1 of 100 is equal to negative 2.96 meters. What is the negative sign indicates? This means that the BM2 is lower than BM1. So class, in surveying, what you measure in the field is temporary, but what you write down and mark is what will last forever. That's why we will talk about the importance of field notes and the field marking of a benchmark. Field notes are the permanent record of all your observations. The numbers you write down become the basis of your computations, maps, and designs. Why are they important? Field notes prevent mistakes. If you make a misreading, it can be checked because it's clearly recorded. They also serve as a legal and professional record of your work. If someone questions your survey years later, your field notes are your proof. Engineers in the office rely on your field notes to compute elevations, draw plans, and design structures. If notes are unclear, the whole project can fail. Now, let's connect this to our earlier lesson on benchmarks. A benchmark is a fixed permanent point of known elevation. If you don't mark it clearly in the field, your reference point can be lost and all your leveling work will become useless. Why do we mark benchmarks? Tomorrow, next week, or even 10 years from now, other surveyors must be able to find this same benchmark. So it can be a reference for future surveys. The benchmark also ensures that all measurements are tied to one reliable point. So class, keep this in mind that your field notes are your survey's memory, your benchmark is your survey's anchor. So let's have another illustrative problems. So here is the sample field notes. You need to complete the differential level notes shown below and perform the customary arithmetic check. Okay, class, let's go through the solution for our differential leveling problem. We always remember the two key formulas. HI, or height of instrument, is equal to elevation plus the backside. Then the elevation of the next point equals HI minus the far side. Now let's start from our benchmark BM1. The given elevation of BM1 is 127.133 meters. We take a backside on BM1 of 1.256 meters. So our first HI becomes 127.133 plus 1.256, which equals to 128.389 meters. Next, to find the elevation of TP1, we subtract the foresight reading 128.389 minus 1.886, giving us 126.503 meters for TP1. At TP1, we take another backside of 1.116 meters. So the new HI is 126.503 plus 1.116 equal to 127.619 meters. From there, we move to TP2, subtract the foresight reading of 1.527, so equals to 126.092 meters. At TP2, we again take a backside of 1.228 meters. Adding these two, 126.092 give us a new HI of 127.320 meters. Finally, we close at BM2 with a foresight of 2.246 meters. So 127.320 minus 2.246 equals 125.074 meters for the final benchmark. Now, let's perform the arithmetic check. We add all the back sides equals to 3.60 meters. Then add all the four sides equals to 5.659 meters. The difference of the summation BS minus summation FS is equal to negative 2.059. We compare this with the change in elevation BM2 minus BM1 is also equal to negative 2.059 meters. Since both sides are equal, our computation is correct. That's how we compute the elevations step by step and confirm accuracy with the arithmetic check.